This lesson is going to look at the volume of prisms. Remember, volume is different from area because the area measures how much something covers. Volume measures how much a object can hold, the capacity. So let's start with this cube. The volume of a cube, the formula is length times width times height. Now, if we look at it, we can see that the length, the width, and the height are all the same. They're all 4 units. There's 4 units going this way, and then there are 4 units going this way. So that's how I know it's a cube. So if I substitute into the formula, I would have volume equals 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the volume is 64. And then when we normally have this, we have some kind of units attached to all these. This particular cube does not, so I'm going just to use the word units. And then because it is a cube, and because we are looking for volume, the units are always cubed, or to the 3rd power at the end of every single volume problem, as long as you are solving for volume. So for example, let's take a look at this particular rectangular prism. The rectangular prism has the same formula as the cube. So my formula would be volume equals length times width times height. So my length from the picture is 7, my width is 6, and my height is 3. So we have to multiply 7 times 6 times 3 all together. So 7 times 6 we know is 42. And then we have 42 times 3, right? 3 times 2 is 6, 4 times 3 is 12. It gives you 126. So I have volume is equal to 126, and then my units this time are feet, and it's cubed. So I have volume equals 126 cubic feet. Rectangular prisms are easy. However, there are other types of prisms that are not necessarily rectangular. What you see in the picture on the screen is not a rectangular prism. That's a triangular prism. When you usually look at triangular prisms, you're not necessarily looking at the bottom of it as its base. The figure is laying on its side so you can see the base. So the base is this triangle right here that I just outlined in red. So when you have a triangular prism, or really any kind of prism, the general formula is this right here. Volume equals area of the base times the height. Because if you were to fill a container, you'd open the top and pour it in, and you would have to pour in whatever liquid you're pouring in, and it would cover the bottom of the figure first, and then that takes care of the area of the base, and then it would rise to the top, which is why you multiply that by the height. So if we take a look at this, the area formula for a triangle is area equals base times height divided by 2. So the base of my triangle is 11, the height of my triangle is 9, and then I have to divide that by 2. So I have the area being 11 times 9, which is 99, and I want to divide that by 2. So to show the process of dividing it by 2, my 99 goes on the inside, 2 goes into 9 4 times because that's 8. I subtract, I get 1. I bring down my 9. 2 goes into 19 9 times because that's 18. I subtract, I get 1. I have to add a decimal and a 0. And then 2 goes into 10 5 times. So my area is equal to 49.5. So then I would take my volume formula and substitute in my area. It was 49.5. Oops, 49, my decimal's here, and a half. And I want to multiply that by the height. And if I were to stand that prism up, that prism would be 12 millimeters tall because the red triangle would become its base. So I would need to multiply 49.5 by 12. So if we do that, 12 times 5, or 2 times 5 is 10. Carry the 1. 2 times 9 is 18, plus 1 is 19. Carry the 1. 2 times 4 is 8, plus 1 is 9. 0 is my placeholder. And then 1 times 5 is 5. 1 times 9 is 9. And 1 times 4 is 4. Add them together. I have 0, 9, and 5 make 14, carry the 1. 9 and 9 is 18 plus 1 is 19, carry the 1, and 5 is 4 plus 1. So I need to move my decimal over 1 because I have one number after my decimal. So I am looking at my volume being an even 594 units, and in this case our units are millimeters, and then it's to the third power or cubed. So the trick when you have a different kind of prism besides a rectangular prism is you have to identify what the base is, and you have to find the area of that base before you can find the actual volume, because when you fill a container, the bottom is what's covered first, which is the area of the base, and then whatever you're filling the container with will rise to the top, which is why then you multiply it by the height. So the same thing happened with the volume of a rectangular prism. Because of a rectangular prism, the base is a rectangle, and length times width is the area of a rectangle. So this part is still the area of the base, so you still cover that bottom rectangle of a rectangular prism when you pour something inside of it, and then it's multiplied by the height because it would then fill up to the top of the container.